today is just an extension of what we did on Friday. So if I had the square root of 24, does 24 square root into an even whole number? No. 25 does, but 24 doesn't. So what do we do to simplify 24? We do the factor tree. 4 and 6, 2 and 2, 3 and 2. Now what? And first I want to remind you, get rid of everything that factored. Okay? And now we circle pairs. I have a pair of 2's, and then I don't have any others. Now what? For every pair, you bring one of those to the front. So I take this 2, and I pull it out and stick it in front of the square root. 2 times the square root. And the leftovers are a 3 and a 2, and 3 times 2 is 6. So apparently, the square root of 24 is equivalent to 2 root 6. And let's just try it to make sure. So the square root of 24, and then 2 square root of 6. And I get the same number. And what we're really doing is taking out the perfect squares. So the perfect squares are 1, 4, 9, 16, 25, 36, and so on. 7 times 7 is 49. 49 is a perfect square. 8 times 8 is 64. So 64 is a perfect square. And really what I did is I took this 24 and I separated its perfect square from the rest of it. It's sort of like saying the square root of 4 times the square root of 6. 4 times 6 is 24. But this piece will square root and turn into a 2. Okay? All right, what if I had, let's say, the square root of 72? What goes into 72? 8 and 9, 4 and 2, 2 and 2, 3 and 3, and I'm going to go through and get rid of everything that factored. Do I have any pairs? A pair of 2's and a pair of 3's. So it's sort of like saying this is a 4 and this is a 9, and then I have a 2 left over. So the square root of 4 is 2, so I can bring 1, 2 to the front. And the square root of 9 is 3, so I can bring a 3 to the front. And this 2 stays behind. It doesn't come out. I end up with 2 times 3 times the square root of 2, which is 6 square root of 2. That's how you simplify square roots. And what we really did was we pulled out a 36. 36 times 2. The square root of 36 is 6, and the square root of 2 stays behind. All right? What if I had this? The square root of 210. What goes into 210? (21 and 10). That's a good one. What can I bring out? Nothing. So the answer is this. That's sort of like saying simplify 3/4. It's already simplified, so we don't need to do anything. Okay. What if we had 150 x squared y to the 5th z to the 6th? 150 is 15 and 10, 5 and 3, 5 and 2. Can I bring anything out? I have a set of 5's, So I write a 5 on the outside. Can I bring anything else out? Well, I have x squared, which is x and x, so I can circle one set of x's. And I can bring out one x. How many y's can I bring out? Well, if I write that out, y, here's a set, and here's a set. The outside is y squared, and there's going to be a y left over on the inside. And then the z's, I have 3 sets, which means I put z to the third on the outside. And, oops, not equals. What's left? I have this 3 and this 2 left over, which makes 6. And all of the x's are gone, and all of the y's but 1 are gone, and then all of the z's are gone. Does that make sense? Okay. What if I had this? What if I had the cubed root of 81? What goes into 81? 9 and 9. And that breaks down into 3, 3, 3, and 3. What am I looking for in this case? I'm looking for triplets, because this is not a square root, it's a cubed root. So now instead of circling groups that have 2 members, we circle groups that have 3 members. So I circle a triplet, and for every triplet I write 1 on the outside, and then the leftover stays on the inside. Okay? Let's do 48. The cubed root of 48, x to the 5th, z to the 10th. 48 would be 8 and 6, 4 and 2, 2 and 2, 3 and 2. And I get rid of everything that factored. Oh. Do I have any triplets? I have a triplet of 2's, and then I have a 3 and a 2 left over. So on the outside, I can write 2. How many x's can I bring out? Well, 1, 2, 3, 4, 5. I can circle 3 of them, and that's one set. And then I'm going to have 2 left over. What about the z's? I don't want to write them all out, but how many 3's are there inside of 10? 3 with 1 left over. So I can bring out z to the third. And then my leftover numbers are 3 times 2, which equals 6. And I have 2 x's left over and 1 z left over. Does that make sense? Okay. If you have a cubed root, there's an interesting thing that can happen. What is the cubed root of -8? -2. If I tried to take the square root of -9, what's the answer there? It doesn't have one. What number times itself is -9? Well, 3 doesn't work. 3 times 3 is 9. -3 doesn't work. -3 times -3 is still 9. What about 3 and -3? That's not the same number. So this doesn't even have an answer yet. It will eventually, but today it doesn't. But when you do cubed roots, what number times itself is -8? -2. So anytime you have a negative inside a cubed root, that negative can come to the outside. For instance, so let's say we have the cubed root of negative 80 x to the 8th. 10 and 8, 2 and 5. When I factor 8s, instead of doing 2 and 4 and 2 and 2, I just do 2, 2, 2. If that doesn't make sense to you, don't do it. But that's just, I know that 8 is 2, 2, 2. Okay, what am I looking for? Triplets. Do I have any triplets? Yes, I have triplets of 2. So I bring a 2 to the outside. What about with the x's? 2 triplets with 2 left over. So x squared. And then on the inside, I have a 5 and a 2, which equal 10. And then I took out 6 of the 8 x's. X squared. Make sure you put the 3 in here. And negative goes where? In front. Like that. Does that make sense? Okay. Let me double check something. All right, 4, 1. What if I had the square root of 16 over 25? Well, you can split this into the square root of 16 over the square root of 25. If you square root a fraction, it's equivalent to the square root of the top divided by the square root of the bottom. Well, what is the square root of the top? 4. What's the square root of the bottom? 5. So that is simply 4 over 5. They do get a little bit more complicated. Not much, though. So if we have the cubed root of 64x to the 6th over the cubed root of 125 y to the 9th. On top, we get 8 and 8, 3, 3, or not 3, sorry. 2, 2, 2, 2, 2, 2. Do I have any triplets? 2 sets. What's left over? Nothing. So on the outside, I get a pair of 2, or a triplet of 2s and a triplet of 2s, which gives me 4. What about x's? I have 2 triplets. I can bring out x squared. What's left? Everything came out. So what do you do when everything comes out? You just leave the square root alone. And actually, it's the cubed root of 1. We took everything out. We divided out everything, so we're left with 1. But the cubed root of 1 is 1. So we don't even bother writing that. Okay. In the bottom, what goes into 125? 5 and 25. 5 and 5. Do I have any triplets? Yep, a triplet of 5s. What about y's? Y to the 3rd. Does that make sense? All right, let's see. That takes us through the first page. Nope, we're not going to do that. Okay, something that is new. What if I had 5 square root of 3 minus 2 square root of 3? Can you simplify that? How? Well, it's sort of like saying 5x minus 2x. What is 5x minus 2x? 3x. So what is 5 square root of 3 minus 2 square root of 3? 3 square root of 3. Do you guys see that? Okay. What about this? 4 square root of 2 plus 6 square root of 3. How do you put those together? Nope. You can't. Why not? It's like saying 4x plus 6y. They don't mix. The square roots are not the same. So that one does not simplify. All right, what if I had the square root of 24 plus the square root of 48? Wait, no, that's not what I want. Hang on. The square root of 54. Do those go together? Not yet. They might go together, but right now they don't. So 24 can be simplified into 4 and 6, 2 and 2, 3 and 2, 9 and 6, 3 and 3, 3 and 2. Does the first one have any pairs? Yes? 2 times the square root of 6 plus, what's the other one? 3 times the square root of 6. Do those go together? Yes. What is 2 root 6 plus 3 root 6? 5 square root of 6. So in the original problem, it doesn't look like they simplify. But once you pull out the factors and eliminate the perfect squares, then you get two like terms and you can stick them together. Okay? You can only add or subtract radicals if the radicals are identical. They have to have the same root and the same number on the inside. Okay? So if I had the square root of 50, or sorry, the cubed root of 54 minus the cubed root of 81, this would be 9 and 6, 3, 3, 2, 3, 9, 9, 3, 3, 3, 3. Do I have any triplets? A triplet of 3s with a 2 left over, a triplet of 3s with a 3 left over, 3 cubed root of 2 minus 3 cubed root of 3. What's the answer? It will be negative 1 cubed root of 3. Do I need to write the 1? Nope, you can just say negative cubed root of 3. Okay, does that make sense? Jenny, you all right? Oh my goodness. I'm so sorry. I did this in my head wrong. So, wow, I'm glad you guys are paying attention. This does not simplify. Thank you. Yep. The 2 and the 3 are not the same, so it doesn't simplify. Okay, good. I'm glad you guys caught that. I built it in my head, but I built it wrong. So, thank you. So we better do one that's going to be right. I'll do this one the right way. So the square root of 54, and then the square root of minus the square root of 250. I think I did this one right. We'll see. 9 and 6, 3 and 3. Oh no, I want cubed root. 3 and 2. 50 and 5. 5 and 10. 2 and 5. Now do I have any triplets? triplet of 3s, and a triplet of 5s. 3 cubed root of 2 minus 5. There we go, I did it. Does that simplify? Negative 2 cubed root of 2. I'll get it right eventually. Okay, what if I had the square root of, let's say, 8 times the square root of 18. What does that equal? Well, it's just the square root of 8 times 18, which is 144. What is the square root of 144? 12. If I have one square root multiplied by another square root, then the stuff on the inside just multiplies together, and then I can simplify in 12. But what if I simplified each square root first and then multiplied? 8 is just 2, 2, and 2. What can I bring out? A set of 2's. So 2 root 2. 18 is just 2 times 3 times 3. What can I bring out there? A 3 with the root 2 left over. Now, when I multiply these together, how do you think you multiply a simplified square root times a simplified square root? You multiply outsides and insides. Okay? What happens when I multiply the outsides? I get 6. What happens when I multiply the insides? I get the square root of 4. What is the square root of 4? 2. So 6 times 2 is 12. So you can multiply square roots as long as they're both square roots. Can you multiply a square root and a third root? No. So if you have a square root times a square root, it's simply outside times outside times inside times inside. All right? So if I had 3 root 5 times 2 root 10 times, or plus 5 root 2, I need to distribute. I need to take this and multiply it in there, and then I need to multiply it in there. What happens when I multiply 3 root 5 times 2 root 10? Well, I do outside times outside, which is 6, and inside times inside, which is 50. For the next one, outside times outside is 15. Inside times inside is 10. And then I need to double check, does anything simplify? Well, square root of 10, what are the factors? 2 and 5. Do I have any pairs? Nope. What is 50 made up of? 5, 5, and 2. So this is 5, 5, and 2. Can I bring anything out? Bring out a set of 5s. What do I do with it? Put it right there, and what do I do with the 5 and the 6? Multiply them, so 30 root 2 plus 15 root 10. Does that make sense? So when you add square roots, the root and the stuff on the inside have to be identical. When you multiply square roots, as long as it's a square root and a square root, you do outside times outside and inside times inside. Okay? All right. We are going to be working on 197, and there are a bunch of it we don't want to do. So 4.1, we are going to work on 13 through 36 odd. And then We will skip the next 3 sections. And we will do 75 to 89 odd. And that'll be it. All right. Good luck.